Welcome back again. My name is Dr. Avitech, and like I've said, I'm going to be solving exposed questions for physics. I didn't put physics there. This is because a lot of students have requested that I come up with questions that would possibly be in the exam for JAMB 2026. If you're that student who wants to score high, you've looked at yourself, you've looked at the university you want to go to, you've looked at the course you want to study, and you need a very high score, you could actually get that score from physics. So if you want to make sure that your score is very high for this year, you need to watch this video completely and then share it across to your friends. Remember to hit the subscribe button, like this video, and share it across to your classmates. So this question says, a proton and electron move perpendicularly into a magnetic field. If both have the same kinetic energy, which of the following statements is correct? A, the trajectory of the proton is more curved, electron is more curved, trajectories are straight lines, they are equally curved. Well, the answer is going to be B. Because when it comes to trajectories, an electron is much more smaller. The radius is much more smaller, so it is more curved because it is small. So the answer for that one is going to be the electron is more curved. The next one, an aeroplane took off with a tire pressure of 2 times 10 to the power of 5 Newton per meter square. At the end of the flight, the plane landed with a tire pressure of 3 times 10 to the power of 5 Newton per meter square. Calculate the temperature of the tire after the flight, assuming the volume is constant. Well, to solve a question like that, since volume is constant, this means P1 over T1 is equal P2 over T2. That's what it basically means. So P1, that's the first pressure, the initial one. That will be 2 times 10 to the 5. Then you could see in the equation that we're not given the initial temperature. Of course, if this plane has been resting for some while, we're going to just assume that it's at room temperature or standard temperature. So that will be 27 degrees Celsius. Now, we need to convert that to Kelvin because when you're dealing with this, you must make sure your temperature is in Kelvin. So, to change that to Kelvin, this will be 27 plus 273. Do not forget, change to Kelvin. All right, so P2, which is the second pressure, will be 3 times 10 to the power of 5. And then our T2, that's what we're looking for. Now, this is 2 times 10 to the 5 over 300 equals 3 times 10 to the 5 over T2. There's an easy way to make some sort of formula here. So I'm going to take this one to this side. Yep, it's like cross multiplying. So let me just do it carefully. 2 times 10 to the power of 5 T2 is equal to 300. We times this. So that's 300 times 3 times 10 to the power of 5. And of course, to find T2, divide both sides by 2 times 10 to the power of 5. Do that and you get your answer. So this will cancel out. So our second temperature, I've not yet solved this. Okay, so let's see. 300 times 3 will give us 450. To give us 450. So this will cancel out. So this is 450. And then divided by 2, that will be around 225 if I am not mistaken. Hold on. Think I'm not... Hold on. 450. Okay, I went to divide twice. That was what I was getting 225. I went to divide twice. So the answer is going to be 450, but it's going to be in Kelvin. So remember that the answer has to be in Celsius. So to get our Celsius temperature, we're going to remove 273 from this. So T2 is 450, take away 273. And of course, when you do that, you're going to get 177 degrees Celsius. That's what you should be getting. But if you look at the option, this is the closest, 174. Yep, so it happens sometimes. That's the closest. So we just have to pick it. So let's move on. The next one is number 3. An electric heating coil is rated 1000 watts, 240 volts. If it is 80% efficient, what is the resistance of the coil? So to get started with question 3, we know that we have our power, so power, then we have our V We have our voltage, we're looking for resistance. So this will be V squared R. It's going to be V squared R. So to find R, we're going to divide by V squared. Okay, hold on. Let me see. V squared over R. Sorry, not V squared R. V squared over R. Okay, so when I put over 1 here and I cross multiply, so this will become V squared equal PR. So to get R, I need to divide by P. So P we cancel at P, so R is equal V squared over P. Now our voltage is 240, so this will be 240 squared over 1,000. So that's equal to our resistance. And that should give us around 57.6 ohms equal to resistance. So that's B. Now you might be wondering why we didn't use the 80% efficient. Now the resistance of the coil actually has no business with the 80%. It's going to be on what it is rated. Because ideally the coil is actually working at 100%. But because there will be some losses, that very loss is going to be accounting for this 80% efficient, so the loss is 20% efficient. In this case, we're not using this because what the coil is using is 1,000. It's only the losses and extra work that is making it becoming 80%. So if you're finding the resistance, it has no business on that 80. Let's move on. Question 4. I'm going to try to solve question 4 here. All right, for question 4, the threshold frequency for tungsten is this value. What is the work function? Now, there's this thing about JAMB. They do not actually set questions with facts. You know, they're just trying to solve a equation. What they do, they come and change this number and just do some manipulation of the numbers. But that's a problem. It's a problem in itself because the actual question, this very guy, the actual one has a minus here. That's terribly low for the frequency of tungsten. Very, very low. So this has to be, it should be positive. It should be. So, but in a case where it's negative, use it like that, but your answer will not be in the option. That's the problem. So we have that as positive. So the work function is going to be HF. We're not even giving H. So what this means is sometimes in physics, you just have some constants in your head. So H is 6.6 times 10 to the power of minus 34. And then times the frequency that we've been given is 2.5 times 10 to the power of minus 18. Because it cannot be minus. It's not possible. So when you multiply this, you should be getting around 1.65. Well, let me just open another calculator. So I just do that. So we're going to be having 6.6 times 2.5. That's the first thing you do. So you get 16.5, and then times, for the 10, you're going to do minus 34 plus 18. So that'll be minus 16. Now, you need, for it to be in standard form, you're going to take this decimal point once. So that becomes 1.65 times 10 to the power of 1 times 10 to the power of minus 16. So this will be 1.65 times 10 to the power of 1 minus 16 is minus 15. And in fact, yep. So the answer is going to be C. Yep. But of course, if this was negative in the original question, I had to, when I saw the question, I had to, because JAMB would, let's move on. Number 5. Number 5 says, the speed of sound in air at X Kelvin is this value. And then, what is the speed at this very guy? So the first thing to know is V, which is speed, is proportional to the square root of that temperature. It's proportional to it. All right. Now, this means that I can actually say that V squared is equal T. We're like, okay, V squared is proportional to T. That's a better way to put it. Yep, so that's what it means. Now, our V, where's this guy? So this means that v squared over t is a constant. V squared over t is equal to constant. So our first v was y, so this will be y squared divided by our second t, that's our temperature, our first temperature, will become x. So this will equal, what was the second v? That's what we're looking for. So this is v squared divided by our temperature is 4x. Now, as you can see, this can actually cancel this out. They can actually cancel out. So 4 will then go here. So this is 4y squared equal to v squared. To get v, we take the square root of 4y squared. So square root of 4 is 2, square root of y squared is y. So that should be the answer to this question. We should be getting C as that value. Okay, number 6. Take note, what I used here was like all those Boyle's law guide. We did v squared 1 over t1, then v squared 2 over t2. That's what I used here. Okay, let's move on. Question 6 says a conducting wire of length 2 cm and cross-sectional area 4 cm was used as a resistor in a circuit. If the resistance is this, you have to calculate its conductivity. So first, they could either ask you to find conductivity or find resistivity. So it's something that they can do. So first, you need to know this formula that resistance is resistivity L over A. So this thing you see here is resistivity. Now, let's say that we find resistivity, like we make resistivity the square root of the formula. We're going to put over 1 here, so this will times this. So 1 times rho L, we give rho L, equal R times A will give R A. Now we're looking for this, and I'll tell you why pretty soon. So this is resistivity equal R A over L, because we need to divide both sides by L. So this is the formula for resistivity. Now what is conductivity? Conductivity is the inverse of resistivity, because if something is not resisting, it's obviously conducting. So if you're not allowing the flow, you're basically opposing the flow. So conductivity would then be the opposite, or which is the inverse of this. So to get that, this will become inverse this, you're going to have R over R A, L over R A, sorry. So what is our L? The length, 2 cm. So that's 2 times 10 to the power of minus 2. When you convert it to meters, that's what you get. The resistance is 2. Resistance is 2. And then times, this is our area, 4 times 10 to the power of minus 4. Remember, remember, this is centimeter squared. Centimeter on its own is 10 to the power of minus 2. So if you square it, you're going to have 10 to the power of minus 4. Learn all of these conversions. Learn them. Now, if you divide this, you should get 25 SM inverse. That's what you should get when you divide. Yep. So that's what you're going to be getting. Okay. Yes. But then there's a problem with the options. Yep. There's a problem with the options. And this equation, unless JAMB will correct it, this very equation was left as 250. It should be 25, not 250. But in the exam, since we have to pick an option, we select A for peace to reign. We select A. But ideally, this very thing should be 25, not 250. Let's move on. Okay, I can rule a line here. Where will an object be placed at the principal axis of a concave mirror of focal length 10 cm to obtain a real image that is twice the object? So, the original length is 10. Now, you want the position that you're going to keep it, you want it to double the image height. So this is 10. You want the height to now be at 20. Basically, you have to put it at the middle. So we have 10. This is the original one is 10. Now you want to place this very object to make sure that it's now 20. It's going to be in the middle, which is 15. So that's 15. Yep, that has to be the answer. That's the only place for you to place the object in the principal like this for you to get double. That's how I like answering the equation. 15. Next one. Two bodies A and B are traveling in the same direction. Same direction, you basically subtract. With velocities 30 meter per second and 80 meter per second respectively. What is the velocity of the body A? So we're doing body A first. This number 8, body A first. So the velocity of A is 30. So that's 30 ms minus 1 minus, because they're in the same direction. Relative to body B. Body B is 80 meter per second. So in subtract, you get minus 50 meter per second. So the answer to that becomes D. So that's it. That would be the answer. If the net force, question 9, if the net force on a body is 0, then the body is said to be in equilibrium. The body is in equilibrium. That's what it means. Because we're saying that this body that we have is the force on this side and the force on this side. The sum of every single force is 0. So it's in equilibrium. That's a better way to put it in science. All right, let's move on to the next one. Question number 10. Question 10. Okay. Let's see. 8, I've done 9. So this will be 10. Two movable pulley systems with efficiency 55% move the load through a distance of 25 meters when an effort of 5 Newton was applied. But to calculate the weight of the load, to start with, I like writing my efficiency as 0.55 because that's what 55% means. Then secondly, for two movable pulley systems, in fact, when pulleys are connected in a movable system, the velocity ratio is always 2 to the power of how many pulleys there are. So in this case, this will be 2 squared, so that's 4. That's what we're going to be getting. It's going to become 4. Now remember that efficiency is mechanical advantage divided by velocity ratio times 100%. Now this very value here is 0.55 equal MA, which is the mechanical advantage is not known, divided by VR is going to become 4. So MA will become 0.55 times 4. So that should be around 2.2. That's the mechanical advantage. Now the next thing is, remember that mechanical advantage is load over effort. Is the load divided by the effort. So in this case, we are looking for the load because we have our effort of 5 Newton. So to get load, you could put over 1 here and then this will multiply this. 1 times load will give us load equal the mechanical advantage times effort. Now, what's our mechanical advantage is 2.2. The effort is 5 Newton. So this should be giving us 11 Newton. But the sad thing is, there is no 11 Newton in the options. This is what the answer is supposed to be. But there is no what? There is no 11 Newton in the option. So what's going to happen is, unless they didn't use this, unless they said two movable pulley, unless they used the velocity ratio as 2. If you use your velocity ratio as 2, so when you do that, your load will then become 2 times 0.55 times 5. So when you do this, you then get 5.5. So that's another way that this can be done. But of course, it's not supposed to be right because this should be giving you a velocity ratio of 4. So the only way to get a 5.5 is if you then use your velocity ratio as 2. So that's just it. So this will be for this very equation. Let's move on to the next set. All right, question 11 says the lower and the upper fist points are used in thermometry for thermometer calibrations. Yep, that's what we use it for. So like it's saying lower and higher. Lower is ice, then the upper one is the highest point. I don't want to go into details for that. Okay, so vapor in a state of dynamic equilibrium is said to be saturated. That's the answer for that. The energy released by the degradation of organic materials, keyword organic. The answer is biomass. That's what it's going to be. The answer is going to be what? Biomass. Which of the following is a property of a permanent magnet? It has to be this one. Okay, first of all, this cannot be this. It's going to be, it has north and south pole. And I believe every other magnet has it. Let me even check what this would be. I'll come back to that. That's what I'll just come back to that later. Okay, the next one is number 15. So a car of mass 200 kilogram moves around a circle of radius this with a velocity of this. You have to find the coefficient of friction. That's number 15. So the coefficient of friction, mu, in this case is going to be v squared over rg. So this will be v is 10. So that will be 10 times 10 divided by our radius is 20. So that will be 2 times 10 to the power of minus 2. And then times our g is 10. Well, this will take care of this to even start with. 10 over 2 is 5. Then when this 10 squared comes up, it becomes 100. No, that's weird. That's weird. That answer cannot be. Yep, this answer cannot be. So it cannot be this answer. Okay. Oh, this is even 20 cm. Sorry. So this has to be 20 cm. So that's 20, and then, yeah, 0 cancels, so that means there's no 0 here. 50. But it's still weird. It's weird because, see, let me tell you the truth. These questions have actually been sent. This very question, JAMB set it. So unless they come change this, which I feel like what they would have done is the V is 1. Because it's when the V is 1, that's when you then get 0.5. And in fact, if I get 15 in the exam, I'll go pick 0.5. Because remember, when you're talking about coefficient of friction, it's always in the 0 point something. So I think they wanted to write the V as 1, not 10. Because if this is 1, that means we'll have 1 squared over 20 times 10 to the power of minus 2 times 10. So with this, 0 times 0 is this 0 here. Times this will give us what? It will give us 100. So the 100 and this guy will cancel out, leaving us with 1 over 2. So that's now 0.5. You can use a calculator for that. So that's it. Let's move on to the next one. Number 16. That's a calculation. Calculate the time taken by a 1500 watt heater to raise the temperature of 150 kilogram material of specific heat capacity this through 20 Kelvin. Remember that quantity of heat is MC, change in temperature. Now that quantity of heat is actually power times time. So that's equal MC, change in temperature. Now we're looking for the time here. So that means we need to divide by what? By P. So this will be MC, change in temperature, divided by time. Now what was the mass? The mass of the body is 150 kg times, what is our C? 960. What's the change in the temperature? It's 20. Divided by, what's the time? Oh, sorry, I said divide by P. Divide by P. So P is 1500. Well, if 10, sorry, let me just, I think I've calculated this before. So this will give you 1920 seconds. So the answer is A. I don't want us to waste time at all. Number 17. Find the radius of a bubble if the pressure difference between a spherical water bottle is this, then surface tension is this. First of all, the change in pressure, I was saying temperature, the pressure difference or change in pressure is 4 times the atmospheric, I said that. The change in pressure is 4 times the surface tension over radius. So this means that radius is 4 times surface tension divided by the change in the pressure. Yep. So this will become 4 times 7.2 times 10 to the power of minus 2. Then the change was 10. So if you do this, you're going to be getting 2.88 times 10 to the power of minus 2 meters. But there's no one that's close to that here. The one that would have been close would have been this. But then, if you look at the scaling, of this, if this were to be 2 times the surface tension, the answer would be C. So in fact, I'll be picking C as the answer because JAMB could have made a mistake, but this should actually be 4 because we're talking about a spherical water bottle. So the bubble, the pressure here is going to be 4. This constant has to be here. But of course, the answer is not there. Yeah, the answer is not there. So I don't want to pick this one because it's very far. So this one is better because this is a scaling of this. If you double this, you get this. So that's why I'm picking that. Okay, question 18. The magnitude of a unit vector is unity. They're not going to tell you now. The magnitude of a unit vector is unity. So it's 1. So let's move on. A catapult stretched by an average force of 70 Newton extends by 0.1 meters. Calculate its elastic potential energy. It's in Hooke's law. That's where you find this. So that's question 19. Now remember that the energy will become half Fe. That's what it's going to be, half Fe. So in this case, this will be half times our force is 70 Newton times the extension made was 0.1. So half of this is 35. Half of 70 is 35. 35 times 0.1 is 3.5. So that will be the answer. That will be the answer. So that's number 19. Number 20. A buoyant force of 2.9 Newton. Since it's buoyancy, we will call it upthrust. Call it upthrust. So that's question 20. So a buoyant force of this was observed underneath a pan floating on a liquid with this. This is volume. Calculate the density of the liquid. All right. So rho, which is the density, is going to become the upthrust. Let me call that upthrust instead of using force. So upthrust divided by Vg. So that's what's going to be the density. Now, our upthrust U was 2.9 Newton divided by volume is 27 times 10 to the minus 7. Then G is 10. Now, if you do this, if you calculate that very value, calculate this very value, you get 107,407 kilogram per meter cube. This is what you will get. Hold on, I didn't write the option. I did not write the options. Okay, let me put the options right here. So A, 1074 kilogram. Okay, B, 950. C, 780. Then D. All right. So if you look at this, you can tell that the answer is close to A, but it's not exactly A. But anyways, now JAMB with the right, so we're going to pick A. But ideally, it should not be. It should not be, because this value is very, very large. It's very, very large. So, but anyways, A is the closest, so we have to just pick A. So I don't know where this 07 went to, but that's what we're going to have. The next one is number 21. Now, number 21 is very, very similar. They can ask this question in 2 ways, and I think it's in the other paper type that I did. It's in the other paper type. They were asking something that has to do with, they were talking about wavelengths in that case. But this one, they're talking about frequency. Now, in the color spectrum, violet has the highest frequency. It's down, it has the highest frequency. It's violet that will have the highest frequency. So take note of that. Now, violet now get the highest frequency. Next one is number 22, which we have to solve. So number 22 says, what is the wavelength of the fundamental frequency if a 14 cm tight string gave a harmonious sound? Now, in this case, it's going to be 2L. The wavelength is going to be 2 times the length. I think in the second paper type also, I solved the question that has to do with double the length. That will be the wavelength. Because when you give a harmonious sound, you're basically going up and down. So that very up and down, remember what a wavelength is like, kind of like the distance between either 2 trough or crest or what have you. So this will be 2 times 14 cm. So this will be 28 cm. So this will be 28 times C is 10 to the power of minus 2. So the answer is going to be C. That's what the answer is going to be. Yep. Let me see. I don't think there's enough space for me to solve an extra one there. If there is, I guess there is. So let me just put it there. Number 23. Let me call it 23. So the question says, in a parking orbit, the satellite revolves the Earth exactly. Okay, it revolves the Earth once in every dash. So the solution for this is it's once in every 24 hours. But then we want to convert to minutes. So this will be 24 times 60 minutes. And then this will be 1440 minutes. So the answer for that is going to be B. Remember to hit the subscribe button and like this video. I did try. Remember to hit the subscribe button. You know, easy. Because what I wanted to do was just maths, but I'm not adding physics. So let's proceed. Remember to share this video. Let's move to the next one. So let's proceed. Question 24. When a magnet moves in a coil, it induces an EMF whose strength depends on the following, except, of course, the EMF would depend on the strength of that very magnet, the speed of the magnet, the number of turns of the magnet. Now, it would have been dependent on this if they talked about the flux, but they didn't. So the answer to the question is going to be B, resistivity of the coil's wire. It doesn't depend on that. So it only depends on the flux change. So 25. A short-sighted man needs a lens of focal length 20 cm to make correction to his sight. What should be the power of this length? First of all, I think I'm going to divide this into two. All right, question what? 25. Now we know that power is 1 over F. It's 1 over F. Now in this case, he's a short-sighted man. So it's going to be negative. And okay, so this will become minus 1 over, the focal length is 20 cm. So I'm going to say 20 times 10 to the power of minus 2. Now this will be minus, let's look at it this way. 1 over 2 means 0.5. Then there's a 0 here. And then this is minus 2. This is 1, a positive 1. So this has to be 10 to the power of 1 coming up. Is there a better way? Okay, let me do it this way instead. Wait, let me do it this way. So this will become minus 1 over this will give 0.2. So minus 1 over this will give 5. Minus 5 diopter. Yeah, diopter. So that's what we're going to be getting for that one. Number 26. The temperature of a boiling water does not change. So the answer for that one is A. The temperature of a boiling water does not change, even though heat is constantly being applied, because dash. When the water is boiling already, if you like increase it, that very temperature is still the same. Because when it starts vaporizing, take note that anything that has to do with water vaporizing or turning into ice, that these two things depend on latent heat. When it's vaporizing, it depends on the latent heat of vaporization. So if it's already boiling, so they said of boiling water, if it's already boiling, it depends on the latent heat of vaporization. But then, if it is turning into ice, so it is now below 0. When this happens, in fact, I think I'm turning into ice, but it will be very cold at that very 0. That depends on latent heat of fusion. So in this case, the temperature of a boiling water does not change because it requires what? The latent heat of fusion. So, I said fusion, vaporization. All right. So that will be it. Now, an electron falls from energy level of minus 5.44 electron volts to another level E. If the emitted photon is of this wavelength, calculate the energy change. So that's question 27. Now, energy change, first of all, is HF, and then this is same as H. We're not giving F, so this will become HC over lambda, because frequency will become C, that's velocity over lambda. All right, so that energy change will become H, which is Planck's constant, is 6.6 times 10 to negative 34. Then times C, the speed, is 3.0 times 10 to the power of 8, divided by the wavelength is 5.68 times 10 to the power of minus 6. I think I've calculated this before, so I shouldn't be stressing myself with that. Hold on, let me see. Okay, this should give approximately 3.49 times 10 to the power of minus 20 joule. So 3.4, so that would be A. Okay, next one. The principle of operation of a lightning conductor is point action. Point action. A lightning conductor. I think most times, we call it thunder arrestor, but the principle of operation of a lightning conductor is actually point action. Take note of that. Number 29. The half-life, pay attention, if just revise the following. Revise semiconductors, which is, I think we have the equation here, should be this one. Revise semiconductor, that's electronics, revise it. Revise transformers, revise simple AC circuit, revise this guy, radioactivity and nuclear physics. So the half-life of radon is this. 3/4 of radon sample will have decayed in how many days? So how many days will it take 3/4 to decay? To decay means to waste away. To waste away. Take note that this 29. If for any reason, this guy is decaying, the fraction decayed is 1 minus the fraction. Oh, let me turn it out. The fraction remaining is 1 minus the fraction that has decayed. Let me rephrase. They are saying 3/4 will decay. That is, it will go away. 3/4 the decay. You are no longer using it, so it has decayed. What will not be remaining? It will become 1 minus 3/4, because 3/4 means what? Means 3/4. Take note that 3/4, that means 3 out of 4. So what will not be remaining? It will not be 1 out of 4. But take note, if you do SCM, if you're not comfortable with this, 1 minus 3/4 will give you 1/4. So this is the fraction that is remaining. Now, there's this formula I always use. We know that the half-life is 4.5. So what I always do is, I will then say that 1 over my fraction remaining is always 2 to the power of the time divided by the half-life. This is what I always use. So this will be 1 over fraction remaining. This is 1/4. So imagine if you take 1 over again, because I'm saying we should take the inverse of this very answer. If you take the inverse again, this will be 4 equal 2 to the power of t is the time I'm looking for, divided by t half, which is half-life, so that's 4.5. Now this 4 guy is 2 squared equal 2 to the power of t over 4.5. So 2 will cancel out 2. So this means 2 will equal t over 4.5. So put over 1 here. 1 will times t to give us t, and then 2 times 4.5 is 9.0. So that's what we're going to be having as our time. Days. Okay. Now, another way to do this is to say that it will decay into half in the first 4.5 days. Then, it will go again by half. That is, half of half is a quarter in another 4.5 days. So together, this is 9 days. So I think you can use that approach. So the next one, number 30. In a simple inductor AC circuit, the voltage leads the current by an angle of 90 degrees. It's 90 degrees. Now, but you can notice that it's written in terms of pi here. Now, in terms of pi, remember this question 30. Pi is 180 degrees. So how do we get 90? If we divide 180 by 2, you get 90. So the answer is equal to pi over 2 radians. So that will be the answer. Number 31. How does the electrical conductivity of semiconductors change with increasing temperature? I'm going to briefly explain this part. So we basically have like 3 materials in electronics, though one of them is almost useless. Insulator, conductors, and then semiconductors. Now, insulators, First of all of these materials, they have 3 gaps in them. Inside their structure, they have 3 gaps. So this very gap is the valence band. This is the conduction band. Now this very guy, they call this the forbidden, this very place is called the forbidden energy gap. That's what this place is. That's what this very place is. So this is a gap. It's a space between the valence and the conduction band. Now, I don't really have the strength to draw the way it's going to look for the 3 structures. But take note, for as long as you're talking about a structure like this, as long as you're talking about the 3 of them, valence band can never be empty. It's either partially filled or it's always going to have something in it. It's always going to have. Always, remember, going to have something. But this guy, sometimes it can be empty, especially if you're talking about what? An insulator. There's nothing, there's going to be no free electron in the conduction band. Because if there is, then it's going to conduct. Now, let's proceed. In an insulator, the gap is very wide that this valence band, no matter how many electrons are here, they can't jump the gap and then jump into the conduction band. You'll be like saying I've got an ion did in between. Anything we even manage, say even jump, it will all enter gutter your waste. Because conduction will only happen when it moves from valence to the conduction band. Now, how about a conductor? A conductor, you see this gap, so in a conductor there is no gap. The 2, valence and conduction, they hold themselves very close, gap no day. So conduction is very, very easy in a conductor. Now, how about a semiconductor? A semiconductor gap D, but the gap is not that much. The gap can close and can open. Like the gap can become narrower or it could widen. So let me give an example. So many of you have seen solar panels. A solar panel is basically made of a silicon material. It's made with a semiconductor material, which is silicon. So silicon is a semiconductor material. Now, the silicon, you notice that your panel, they say for night, they work. But for daytime, like now, sun is shining, they'll say, it does the work, it does the charge. My battery does the charge. If you are increasing temperature, that is, day don't break, sun don't shine, temperature don't increase, you say your panel is now working. Now, what has happened? As you increase temperature, you see this gap, so the gap will reduce. The gap will decrease. As the gap has decreased, more electrons can now move from the valence band to the conduction band. So the answer to this question is going to be C. Because with increasing temperature, the conductivity, that's for you to conduct electricity, the conductivity will increase because more electrons move to the conduction band. Shaking now, that's the answer. Let's move on. Question 32. What is the effect of doubling the diameter of a pinhole camera? First of all, I don't know if you guys have seen a pinhole camera, but as the name suggests, pin, the hole na pin. Now, the way the pinhole camera is being structured, if you double the diameter of that very hole, that is, if you make it bigger, so a wider hole is going to give you a less sharp image. So the lesser the hole, the more sharp the image will be. But the more you increase that very circle, that very hole, the more you widen the diameter, the more, because they want to double it, it's going to be blurred. The image no go sharp again. So you sharp and no sharp. You no go sharp because you don't go double. If you increase that very hole, so you are going to make the image less sharp. Hence, the image will be blurred. So that's the answer. Let me see if I can move to the next one. Sorry, I actually have a class coming up in the next 25 minutes. So I can't, wipe the board and write the next set of questions. So this video is going to end here for now. The video is going to end here. And because my class will take up time, and I want to still release this video today because your exam is tomorrow. So I'm going to release this. Then if there's more time, I will then complete the remaining ones. I have a lot of questions on physics. Stay tuned to this very channel. Hit the subscribe button and like this very video. Bye.